do another one. A 95% confidence interval to estimate the proportion of children that lack consistent food sources, food insecurity in Washington County is between 17.2% and 22.4%. According to the ABC report, nationally, 25% of children live with food insecurity. Suppose instead of the confidence interval that was created with the data, we had conducted a hypothesis test. And here's my hypothesis test, that the true proportion is 0.25, the true proportion is not 0.25 at the 5% significance set. Would the hypothesis test have resulted in the rejection of the null hypothesis or failure to reject not enough evidence of the null hypothesis? But one thing I know that my confidence level is 95%. And then my significance level, I'm just call it SF, is 5%. So notice these two are complementary. The sum of these two, 95% plus 5% equals 1, which is what I need. Great, so now I can compare apples to apples. This is, furthermore, I need another thing. This is two-sided, so two-sided hypothesis test. So now we're comparing the same thing to the same thing. So confidence level is two-sided, and we're using a two-sided hypothesis test. So we've met both criteria. So now we can compare. And as we compare, we note that the confidence interval says we are 95% confident portion of children Now we know that p equals 0.25 is not in that interval. So it is not one of their choices. In that case, we have ruled out p equals 0.25 as a choice. That's no longer a choice. So yes, we have. So in that case, the result of conducting a 5% significance level hypothesis test with the same data is the result of conducting it is to reject null. So yeah, that would have been what would have happened had we conducted the hypothesis. The null would have been rejected. One last one. Consider the following scenario: p equals 0.25, p does not equal 0.25. The result from the data is found to be not statistically significant at the 1% level. So now at the 1% level, it's not statistically significant. Would a 99% confidence interval contain the null hypothesis of p equal 0.25? Since again, we're turning this whole thing backwards, just so we can see it from the other perspective. We're doing a 99%, again, verify that it's 1% plus 99% equals 100%. So they're complementary. Again, this is a two-sided test. Perfect. Now we can compare. And because of that, we can compare the two. Now we found the result from the data found it to be not statistically significant at the 1% level. What does that mean? P-value is not less than 0.01. What does that mean? Would a 99% confidence interval contain the null hypothesis of 0.25? The answer is no. No, it would not. As the resulting confidence interval again, so we can agree with hypothesis test result. So one rejects, the other one should reject. If one accepts, one should accept. But again, accepting or rejecting in a confidence interval is determined by whether the population proportion is inside the interval or is not inside the interval, or null, what we think is the true population proportion.